Hello and welcome to the TTI Distribution Download, the podcast where we talk about all things happening in the world of electronic components with the specialists of TTI.
Thanks, Jim. Hey, everybody, and thanks for plugging into the TTI Distribution Download. I'm Steve Brahosky. I'm a business development manager here at TTI. I've been in the electronics industry for over 30 years, 4 of which have been here at TTI. In this episode, we're welcoming Pat Denton, who's the TTI Technical Marketing Director, and Pete Pytlik, the Senior Manager of North American Field Application Engineering at Littelfuse. Littelfuse happens to be one of our premier circuit protection partners, and we welcome them both here today to talk about overcurrent protection. So with that, Pat, welcome and thanks for joining us today. Could you please tell us a little bit about yourself and your experience in the industry and your time here at TTI?
Thanks, Steve. My name is Pat Denton, and like you, I've been in the industry for about 30 years. The last 10 here at TTI as the Technical Marketing Director. Pete, can you tell us a little bit about yourself?
Sure. I've been with Littelfuse now for over 25, and I'll say plus years. Various capacities, started out in engineering, process development, new product development, test equipment development, software applications for about the last 15 years, and most recently, I'll say over 5 years, the FAE manager for North America.
Thanks, Pete. This first session, we're focusing on overcurrent. Can you give us a brief overview of the Littelfuse overcurrent portfolio and the reasons we need overcurrent protection?
Sure, great question. Maybe we'll start out with, what are the reasons for overcurrent protection? Really, the purpose of an overcurrent protection device is to be an intentional weak link in the circuit. So what are we looking really to protect against? Fires, also any type of injury that may occur. The purpose is also to safeguard any other components in the application. So it's really, again, to be the kind of the first level of protection to protect the circuit.
Can you expand on the construction and then the differences and characteristics of the different overcurrent technologies?
Sure. When we look at overcurrent technologies, there's a number of different technologies available. So we can look at fuses, there's PTCs, which are resettable devices, and there's also integrated type products, protection ICs, otherwise known as E-fuses. So let's take a look at maybe the first one, fuse. So fuse is basically a single opening device. It is not resettable. Construction, available in surface mounts, cartridge style. So actually the construction of these devices will vary on the performance that we're trying to achieve. PTCs, otherwise known as positive temperature coefficients, these are resettable type devices. So mainly for applications where you may expect there to be a fault, and it may be because of a user interaction. So there may be more than one, maybe 5, maybe 10 times in the life of the product. So in those cases, you would want to use a PTC instead of a single opening fuse. And then I mentioned the third one, a protection IC, again, otherwise known as an E-fuse. This is more of an integrated protection device. So in addition to overcurrents, you're going to maybe have also over voltage features, over temperature features, more for board level type applications. Again, where you're looking for more features than just, let's say, a fuse overcurrent protection device by itself or a resettable. So in general, board level mount for E-fuses, protection ICs, also for PTCs. Fuses, they may be board level and they may also be off-board. Larger type applications, industrial. These are going to be your larger type fuses in hundreds of amps, thousands of volts. So again, many different technologies for overcurrent protection, but generally we can narrow it down to the 3 I just mentioned, fuses, PTCs, and protection ICs.
On the resettable fuses, is that a mechanical reset or is it done through circuitry? How does the reset actually happen?
So it's an electrical reset. So on a basic level, what a PTC is, it's a polymer which includes conducting particles. So when a fault occurs, what will happen is that polymer will start to expand. So what will happen then is the conducting particles will now separate. So the resistance can go several orders of magnitude higher. So now, if you have a very large fault, maybe in tens of amps, hundreds of amps, what will happen is that PTC material will heat up, the resistance will increase, and it'll significantly drop that current. And this can be in the milliamps, could be in the hundreds of milliamps, much lower than the initial fault, which again can be in amps, tens of amps, hundreds of amps. So just one more note on a PTC, this is a constant power device. So when it does trip, it will want to keep itself in that state. And generally at that temperature, maybe around 125 degrees. So if it needs to adjust the voltage or the current across itself, it will, again, to keep itself in that trip state. When it comes to resetting a PTC, basically, you do need to shut the power off to the application. In some cases, it may reset itself, and there are certain formulas that can be worked through, certain voltages that you need to be below. But generally, the application does need to be power cycled before the PTC can reset.
I'm really looking forward to the eFuse and the advent of the eFuse, and looking forward to your offering for that as well. Can you walk us through the steps an engineer might use when selecting the appropriate overcurrent protection for their application?
Sure. So it really starts out, are you looking for a single opening type of device, or are you looking for a resettable function? So there are a lot of parameters, specifications that the designer needs to be mindful of. And this will actually apply for all the three different technologies. So really to start out on the most basic level is how much current does the fuse need to carry without opening? Second is, when there is a fault condition, how fast do we need the device to open? Because that's really going to determine what level of protection you're going to get in the application. So currents, voltages, and also if there's any additional features that you're looking for protection. This may include over voltage, over temperature in the case of eFuse.
In the circuit protection world, there are certain standards like UL that come into play when specifying overcurrent protection. Can you explain the different standards and solutions that Littelfuse has?
Sure. So fuses generally fall under two different standards. One is UL, and they'll be generally UL 248. The other one is IEC, and that'll generally be IEC 60127. 95% of the fuses will fall under those two standards. Okay. Just a note on UL specifically, the fuses can be UL listed or UL recognized. So what is the difference there? A UL listed fuse is where we design to UL standards, okay, and specifications, and that includes opening times, certain interrupt rating specifications. When a fuse is recognized under UL, what happens is we design the fuse to have certain opening characteristics, and then UL tests that fuse mainly to see if it meets those conditions and also for safety. So in the vast majority of applications, either or certification will work. There are some applications and product standards that will require a UL listed fuse. Again, that is where we design to UL standards. But for vast majority applications, in general terms, either or can be used. So it is important for the designer to be mindful what the end product standards are, and that the products are certified and will meet those standards.
I imagine it's somewhat application dependent, depending upon the applications being used in terms of end product, as to whether or not you want the UL listing, which is a higher level standard, the way you've just described it. But if the application is benign in terms of safety or performance, maybe it doesn't require the actual listing. Is that a fair statement?
So in vast majority of applications, either or can be used. There are some specific applications, and in the end product standard, they will say that a UL listed fuse is required. This may generally for larger type applications, higher power, powered off of branch type circuits. And generally the designer really needs to be mindful of looking at that end product standard if a UL listed fuse is required or not.
Yeah, thanks. Great answer. And I'm just glad that we have you and your team of experts from Littelfuse to help us whenever a circuit design situation comes up, because there's a lot of things that have to be taken into consideration for circuit design. Have there been any recent advancements in overcurrent protection technology?
Sure. Great question. When we look at advancements, and this is applicable to not only just fuses and resettables and eFuses, generally what you're trying to do is to get as much functionality, and when I say functionality, this generally refer back to the ratings, okay, whether it's current or voltage. So the highest current rating, the highest voltage rating in the smallest package possible. That's kind of been the trend. That's where we spend a lot of resources and engineering expertise, really to get our products, to get the most functionality in the smallest package possible. Having said that, there's also integrated type products that we work on. So it may have more than one type of function within that product. Sometimes there may be overcurrents, it may be over temperature in the same product. So Really, again, from a high level, most amount of performance, smallest package possible, and then also integrated functions within those packages.
Pete, talk a little bit more about the methodology that a designer would use when he's designing in the overcurrent protection in a circuit.
Sure. Let's take an example of designing in a fuse. Okay. So there are several parameters, specifications that the designer needs to be mindful of. And just at a high level, it is current and it is voltage. Okay. So the fuse does need to handle a level of current indefinitely without opening. So you're not getting any nuisance opening. Then the fuse needs to open, okay, when there is a fault condition in a certain period of time. So there are certain graphs, specifications that indicate what that time will be per given fault current. And we also want to be mindful of the voltage, whether it's AC or DC. Some fuses are designed for both AC and DC. Some fuses are designed for either one or the other. And I would also want to point out one important parameter which is often overlooked, and that is the interrupt rating of a fuse. So when we look at fuse ratings, and just as an example, this may be a 5 amp fuse and maybe a 10 amp fuse. Generally, that's the amount of current a fuse can hold indefinitely, but it really depends on the standard. And most fuses will need to be derated for lifetime. So you'll never be actually running that amount of current through that fuse. Again, you'll need to derate for lifetime and then also for temperature. So maybe a 5 amp fuse and maybe a 10 amp fuse. Again, just as an example of a rating. Now, what the interrupt rating of a fuse is, it is the amount of current at a given voltage that the fuse can safely interrupt. So just going back to the example of, let's say, a 5 or 10 amp fuse, that fuse may have an interrupt rating of 100 amps at a certain voltage. So under a short circuit condition, if that source current is available, let's say it is 100 amps, that fuse will safely interrupt. And what I mean by safely interrupt is that the fuse will open, it does stay intact. If you were to exceed the interrupt rating, that fuse may not safely interrupt that current. So you may have a rupture of the package, you may have some thermal events. So it's always important for the designer really to take a look at the specifications, the current to voltage, and then also take a look at the interrupt rating. Again, to make sure that that fuse can safely open up that fault current. It is a specification parameter that is often overlooked, but very important.
Do you ever build redundancy into fusing? Do you ever have like a series of fuses to help make sure that when there is a failure mode that actually it does open the circuit?
Sure. So generally fuses are not placed in series. From time to time, fuses may be placed in parallel. And generally why that would be done is if there isn't a fuse with a specific current or voltage rating, we may parallel fuses. There are special considerations that the designer needs to be mindful of if they are paralleling fuses, but fuses can be paralleled.
Sounds like there's a little bit of art going on with designing in fuses. And again, happy to have your expertise to help the designers when they're going through their circuit design.
Yeah, absolutely. It's been great having you with us, Pete and Pat. Thank you for sharing your knowledge and your insight on overcurrent protection with us today. We look forward to the next episode where we're going to tackle overvoltage, similar but different. And then I want to thank the listeners for plugging in with us today and ask you to tune in again for our next distribution download.
Thanks.
That's it for this episode of the TTI Distribution Download. For more information on any of the topics you heard about today, reach out to your nearby TTI branch at 1-800-CALL-TTI or visit us online at tti.com.